Alright, this is the second part of the Radians video. So in the last video I said try those other 6 problems and those are the answers. If you got one of them wrong, I encourage you to check and try to figure out why. For the top row in blue, you can pretty much just substitute in 180 for pi. So like pi radians is equal to 180 degrees. So that's why 4/3 pi is equal to 240, because 4/3 of 180 is 240. Right? Same thing here, like a negative radian is going to like also be a negative degree measure. That just refers to the direction that the angle is drawn in, as you probably know at this point. Maybe not, but it's negative angles just have to do with direction. So like a 30-degree angle would look like this, opening up counterclockwise. A negative 30-degree angle would look like this, opening up clockwise. So the negative radian will still be a negative degree. So that 210 is 7/6 of 180, alright, and so on and so forth. Now for the bottom row, you're going to multiply by pi over 180. So like I got this by doing 3 pi, oops, my bad, 135 times pi over 180. And then this 135 over 180 simplifies to 3/4 because 135 and 180, they're both divisible by 45. So 3 over 4. Alright, so now let's try 3 application problems to finish this out. So the definition that we learned of radians is how many times the radius fits along the arc. Alright, and that's what this says right here, where it says theta is equal to s over r. Okay, so theta is an angle in radians. So this only works when you're talking about angles in radians. And it's equal to the arc length divided by the radius. Meaning like how many times does the radius fit in the arc length? Alright, theta equals s over r. Now, you could also, so you remember theta has to be in radians, okay? You can also cross multiply and get s is equal to r times theta, which means the arc length is equal to the radius times the angle in radians. Alright, so both of those are the same formula. So now let's use them. So it says find the length of the arc of a circle of radius 18 subtended by central angle that's 7 pi over 6 radians. Okay, so here we have a circle with radius 18 inches, and I'm going to draw an angle here that's approximately 7 pi over 6. And what it's asking is what is the length of this arc given those two things. Now, 7 pi over 6, I'm going to type that in my calculator and see what I get. Okay, so 7 pi over 6 is around 3.663, which means that this arc that I highlighted in red should fit this radius around 1, 2, 3.6 times, okay? So our answer should be roughly between 3 times 18 and 4 times 18. Now, the way we're going to do this here is we're going to use this formula. The arc length is equal to r times theta. So the length of the arc is what we're looking for, is equal to the radius, which is 18, times the angle in radians, 7 pi over 6. Now, you could keep that in terms of pi, or if you multiply out pi, you get 65.94. which in terms of pi, if we now divide pi out, is equal to about 21 pi, okay, inches. So even though it's in terms of pi, it's referring to an arc length, so your answer is going to be in inches, not necessarily in radians, right? So not everything in terms of pi is in radians, okay, but you could have lengths that are in terms of pi, or angle in radians that are in terms of pi. Really anything could be in terms of pi. Alright, now let's try example 2. So it says, find the measure of a central angle that intercepts an arc length of 25 feet whose radius is 10 feet. Okay, so now we have a circle where the radius is 10, and then we have an arc that is around 25 feet. So, in other words, we have to figure out what this angle here is, this central angle, okay? And I'll write it in red. Now, In radians, if we were to find theta in radians, it's going to be 25 over 10 because it's the arc length divided by the radius, which is around 2.5 radians. All right. Now it didn't say whether we have to give our answer in degrees or radians. All right, and 2.5 is not in terms of pi. It's just 2.5 radians. It just means the length of the arc is equal to 2.5 radiuses. So if I wanted to convert that to degrees, I'm going to multiply by 180 over pi. Even though it's not in terms of pi, anytime you go from radians to degrees, you multiply by 180 degrees for every pi radians you divide out. All right, and we're going to get that this is around 143.3 degrees. Okay? All right, the last example here says to find all angles coterminal to 2 pi over 3 and also two specific angles that are coterminal to 2 pi over 3. Now, 2 pi over 3 is the angle given in radians. Since there's no degree symbol here, we're going to assume that it's the angle given in radians. Now, coterminal angles are just like, if this is 2 pi over 3, then any angle that has the same terminal side will be coterminal. Now, we probably learned that you just add 360 or subtract multiples of 360 to find coterminal angles. So now we're going to do the same thing, but with 2 pi. So we're going to add 2 pi times k, where k belongs to the set of integers. All right, and that's how we write that out symbolically. All right, you can write it like this too. K is an integer. Now, I'm running out of time on this video, but to find two specific coterminal angles, what you would do is plug in 1 and 2, any integers in for k here, and you would get two other specific coterminal angles. So you would get, so if you plugged in 1, you'd get 2 pi over 3 plus 2 pi, convert that to 6 pi over 3, and then that simplifies to 8 pi over 3. So that would be one of your angles, and there's an infinite amount of them. You could add or subtract 2 pi as well to find another one.